Good afternoon, everyone. Thank you for coming today. My name is Arlene Johnson. I'm Associate Senior Librarian at University of Cincinnati Libraries and co-director of the Digital Scholarship Center. In terms of what's going to happen this afternoon, I'd like to first introduce Leslie Schick, Senior Associate Dean, University of Cincinnati Libraries. She'll provide some welcoming remarks, and then she'll be followed by James Lee, Assistant Professor in A&S English and Academic Director of the Digital Scholarship Center. So, Leslie?
Thank you, Arlene. So it's my pleasure to welcome you all from UC Libraries, and on behalf of Dean Shima Wang, who is traveling in China and not able to be here today. So I'm very happy to have you all here this afternoon. I'm glad we've almost got a full room. This is actually the 7th event in this Digital Humanities Digital Scholarship Speaker Series. So it's hard to believe we've already had 7, but this is lucky number 7, right? Of course, none of these events would be possible without the hard work of our staff, and just a few people to call out and thank at this point. Obviously, Arlene Johnson and James Lee, Melissa Norris, our Director of Library Communications, Jenny Makowitz, Jason Art, Don Jason, and Dan Gottlieb. So today we're really happy to have Blaine Greatman, Associate Professor of English, and David Eichmann, Director and Associate Professor in the School of Library and Information Science, both from the University of Iowa. Now I'm going to turn it over to James for more information. Welcome. We're really happy to have you here.
So just some context on the speakers today. David Eichmann is the Director of the School of Library and Information Science at the University of Iowa. He has conducted research in relational database theory, software reuse and re-engineering, web search engines and intelligent agents, biomedical informatics, and ontology-based research profile harvesting and visualization. His current projects include Sciencv, which they discussed earlier this morning in Langsam Library, CTSA Search, which aggregates research profiles from 70-plus institutions, CD2H, an informatics coordinating center for the CTSA consortium, and Link Data for Libraries, where he's part of a consortium exploring the next generation of library catalogs. Blaine Greatman is an associate professor of English at the University of Iowa. He writes regularly for popular publications, including The New Republic, Slate, Time, and The Week. His first book was The Poetics and Politics of Youth in Milton's England, published by the Cambridge University Press. And his forthcoming book, Networking Early English Print, is forthcoming with Stanford University Press. And that project is based on Sciencv, a digital project built in collaboration with David Eichmann. Greatman holds an MPhil from Oxford, where he attended on a Rhodes Scholarship, and a PhD from UC Berkeley. And as Blaine mentioned this morning, it's an sort of an odd couple of intellectual collaborators, and I think that's part of the point of why we invited them both for this 2-part presentation. Really to show, one, part of what we do at the DSC is the sort of borrowing of methods across disciplines, and I think that the morning talk and then this talk will show how a lot of the underlying methods can be shared across disciplines. So join me in welcoming Dave and Blaine.
So one of the slides from this morning that Blaine had put together showed how we came into contact with each other, which was basically through a student that was working with him and a student that was working with me, cross-connecting, and the two of us ended up in a room and deciding that the data he had was sufficiently interesting to want to play with. This really actually started by another connection that I had. So back in the 70s and 80s, I used to be an IBM mainframe operator and then moved into VAXes. And my supervisor at the time ended up being Associate VP for Research, and invited me to go to this meeting across the river, and I have to explain across the river vocabulary. So the Iowa campus has got a river running through the middle of it. The west side of the campus is medicine, pharmacy, nursing, dentistry, etc. The east side of the river is liberal arts and sciences, business, engineering. And if you've ever been in Iowa in the middle of January, you know just how separating a quarter mile of frigid wind can generate, you know, two distinct fields to a campus. So Bill Decker, this old friend of mine, invited me to a meeting, and it was basically the planning session for Iowa's initial submission to the Clinical and Translational Science Award program. And so I read the RFA before I went, and I went to the meeting, and it was basically a sub-team working on the biomedical informatics component. If you ever saw the original RFA, that thing's 37 pages long and averaged 2 mentions of informatics per page, right? And so we're going through this meeting, and it's sort of IT people in the hospital telling everybody what it was going to be. And we got to the end of the meeting, and Bill walks over and goes, "You read the RFA?" I said, "Yeah." "Did you notice that it stipulates that we have to identify a designated biomedical informatics director to be part of this consortium?" I said, "Yeah." He goes, "Your name came up." And in the guise of be careful what you wish for, I got to the end of my list of demands, and they were still saying yes. So I ended up having to step down as director of the school, went across the river, had to switch parking ramps, which is not trivial in Iowa City. Fortunately, I had enough stature that I actually was able to swing it, not the least of which is my wife was a stem cell biologist, so she already had the provenance in anatomy and cell biology. But the prospect was that as we started doing this, it was very clear to me as we started interacting on campus and we started interacting at the consortium level, and we actually managed to get funded in the second round. We didn't make the first round. When we got funded in the second round, that campuses didn't know who they had on campus. I mean, you would have people swear up and down that they knew everybody they needed to know about any given protein or any given animal model. And the reality was, when you start digging into the literature, I'd say, "Do you know this person? No, who's that?" Right? And to a great extent on the Iowa campus, that's in part because biology is liberal arts and sciences, is on the other side of the river. Right? But even within the notion of a large teaching hospital, we were talking about hospitals and sizes. You can walk a mile down a corridor in UIHC and still be in effectively a single building, end to end, right? So the prospect of everybody knowing who they need to know gets a little problematic. So we have this thing called Research Week for the biomedical campus, and my PI at the time, who was always very fond of volunteering me for things without actually telling me ahead of time, we ended up doing what effectively was a little electronic brochure in lieu of a printed brochure, which is basically just everybody emailed my team a quick little abstract of what their current research interests were and a picture, and we just basically mocked it up as a quick and dirty little website. And then somebody said, "Well, can't you plug papers in?" And, "Well, can't you plug the grants in?" And the next thing you know, we're running what eventually becomes known as a research profiling platform. So these systems are basically designed to reduce or make completely invisible this notion of information friction. And the idea is, if you want to know who on campus is doing something, if you want to know everything there is to know about a single individual as an open, out-in-the-air researcher, you can go to NIH Reporter for their grants, and you can go to PubMed for their publications, if their publications are in PubMed, which was part of my problem, because all my publications were not in PubMed, and so people didn't believe I published at all, because I wasn't in PubMed. Whole different cultural issue going on there. But the prospect was that that's a difficult thing to do, right? And in the guise of be careful what you wish for, I had to take down our grant component because certain members of the dean's leadership team decided that it was a little too easy for the junior faculty to find out what their current grant history, the dean's grant history were, and to say, well, you haven't had a grant in 6 years, why are you going after me? That's the interesting aspect of friction, is it creates unintended consequences. Part of what we wanted to do as these things started building out, and there was actually a U54 that was funded within the consortium, the CTSA consortium. So at this point, every time I say consortium, it's a Clinical and Translational Science Award consortium. Within the consortium, they picked up a platform called VEVO, and there were, I think, 12 institutions. They did a bunch of build out, and at this point, there's over 100 VEVO sites around the country. Harvard, similarly, built out a platform called Harvard Profiles, which they eventually started migrating around. University of California, San Francisco is probably the second most interesting instance of that, and I'll come back to that in a minute. And then there were some of our, we can't help but build it ourselves, folks. So we built a platform called Loki, that brochure that mutated into a profiling system. Stanford did a system called CAP. Elsevier bought Science, or SciVal Experts, and has mutated it now into Elsevier Pure as a commercial platform. And there are a number of others, larger or smaller, these systems. So looking at all this data, and Blaine knows that I can't resist this, there's huge piles of curated data sitting there that institutions are expending the effort of saying, here's an individual, here's a unique identifier for them, and here's all their publications, here's all the courses they taught, here's where they went to school. In other words, everything that shows up on a CV, but it's sitting there as linked open data. Right? And from the VEVO perspective, it was all a single ontology, a single representation format. Right? And once Griffin, with Profiles, opted to deploy that data in a compatible form, in other words, picking up the ontology for publishing the raw data, we suddenly had a common representational framework that could span a number of institutions. So the prospect was, rather than turning these into a bunch of individual stovepipes, which had their use, what I did instead was basically look at what we could do with jumping across this. Now, the big thing about this, and was most confusing to the community at the time, was they called the project VEVO, they called the software VEVO, and they called the ontology VEVO. Right? So we suddenly had to get into this, well, we're talking about now VEVO the ontology, not VEVO the project, and you get into these weird semantic dances. But it was the case that you could represent things, and you could ask questions that you can't ask of PubMed. You could chase chains of connectivity, right, between grants and the papers that come out and who all is on that. Because part of the problem with resources like NIH Reporter is, unlike NSF, where every grant metadata record includes all senior personnel, NIH in Reporter only tells you the PIs. Right? And that's all well and good, but when you're looking at a UL1 like a CTSA, you've got one PI and dozens, if not hundreds, of senior investigators who are in part and parcel of why that award was made, and none of those people are visible in that space. So from a notion of how do you connect the dots, that became a major driving point. Right, so the other aspect is, once you start getting into this, now all these other tools start coming along. Right? If you haven't looked at your Scopus license recently, there's a VEVO clause in your Scopus license. It's literally called the VEVO clause, right? Which allows you as an institutional licensee to mine Scopus and take that metadata and put it in your profiling system and not violate the license agreement. That's Elsevier. So from a cultural change perspective, that's an interesting side effect. And then you've got the open stuff like NIH Reporter, PubMed, and PubMed Central now. At the time, PubMed Central didn't even exist. GenBank, all the curated data sources that people are now expected to be open with. And now you got lots of dots you can connect if you can figure out who's who. So, version 1 of CTSA search, I had this ideologically pure notion that I would only interrogate their Sparkle endpoints. Sparkle is just the query language by which you can talk to a store of linked data and ask interesting questions and get exactly back what you wanted. And that did indeed function. It also demonstrated that I was capable of pretty much taking down any Sparkle endpoint in the country that I chose to by asking interesting questions. The technology being what it is, it wasn't ready for prime time when you're trying to pull profiles on 125,000 people, which is what we were looking at. So version 2, less ideologically pure, still 10 Sparkle endpoints, because I wasn't going to give that up. But now we picked up an additional 15 VEVO sites that I was doing basically a custom written crawler to acquire. The VEVO platform, you can come in with a special URL, special command, and it will give you a block of data as triples. So it's just a matter of having to ask that question over and over again, sometimes 20, 30,000 times to pick up the data for each of those people. But it was doable, and it didn't take the systems down. And I figured out a way how to do this with profiles too, which is even more mindly simplistic, but does work. So at this point, what's happened is that this has really blossomed out into a complex set of connectors. We've got the original Sparkle query. I have now 2 different VEVO harvesters, and that's because ontologies mutate and the systems, the sites, don't necessarily upgrade because of the inertia of having gone to all the effort getting the first version up. I'm not going to change to the second version just because you guys deploy new code. Still, the profiles thing, 2 platform-specific ones because some of these sites are actually homegrown. We're only showing you HTML. And then Elsevier actually is giving me credentials to Pure with just an email message from a local licensee saying, yes, Dave gets an API credential. And that's actually the lightest, cleanest way I get data, because from there I can say, I only need the new stuff from last week, right? As opposed to having to recrawl the whole environment. And then, as a favor to a friend, I actually wrote one that's comma-separated value table-driven. But, and this is the slide you were supposed to see, James. The upshot is, each one of those sources gives me a connection, right? That is basically platform specific. Yeah? It's got its own internal data model. You pull that stuff up into your local environment, and then you can shape it. And what you shape it into is that unified internal model. That unified internal model now has fused all of the variants into a single integrated data store. At that point, you can project it out any way you want to. So I've got a Sparkle endpoint that speaks 1.4 VEVO ontology, and I've also got a Sparkle endpoint that speaks 1.6, right? It's the same data. It's just what you're doing with that projection. And then CTSA search is just a way of demonstrating you can mash the data up in interesting and pretty ways without having to do anything other than harvest the data and generate a means of querying it. And then the other option is you can push in from the side all these other data sources. So a lot of these sites don't give you full abstracts, right? But if it's a PubMed record and I've got a PubMed ID in their data, you reach over into our cached copy of Medline and you pull the abstract out. You got a copy of PubMed Central, full text, we can go even funkier on that, right? So what that means is you end up with a lot of data. We're roughly 250 million facts, if you want to think about RDF triple as a fact. You know, this person has a co-authorship of this PubMed ID as a simple fact, or this person has this degree. In aggregate, that means you can do a lot of things, but it also means that you can do this, and that is, you suddenly find yourself sitting over here, and when you go to institutional statistics, now we've got this is actually not the freshest data, but it's pretty close. 47 VEVO sites, 16 profile sites. I've only got 4 pure sites so far. That's solely waiting around for things. But then the question becomes, well, how many people do you have? Well, I've got 3.6 million distinct person URIs. In other words, an identifier. And clearly, there are not that many people in play. When you start trying to ask, okay, well, how many unique people are there? You run into what I call the stub problem, and that is Florida stands up a VEVO instance. And for their authors, they've got full-blown URIs. I'm in the VEVO data for Florida twice, right? Because I'm a co-author on 2 different papers, but they don't know I'm me, right? So they create this mock-up identifier, which only has a name as it appeared in the publication and a link to that publication. So when you try to cook all that out, turns out I've got somewhere between 175 and 400,000 unique individuals that are in these profiling systems. And that spans everything from deans and presidents down to, depending upon how the institution has policy, even graduate students being present in these data. It includes everything from grants and publications to education to which courses they teach on the campus. Those types of connections begin to get you to where we'd like to be in terms of treating this as a single environment, a single ecosystem, right? The interesting bit is how dense that network is. So with somewhere around, let's call it 400,000 unique individuals, there's about 7.6 million distinct publications, which if you think about PubMed, turns out to be about a quarter of PubMed, because PubMed's roughly 28 million records. There are 49 million author-author links in this graph, which actually isn't very dense. Because if you think about it, if a publication's a node, it's only about 7 links per. But if you think about how big an author list is on a biomedical paper, that looks like it's pretty much on target. Part of what you want to think about with this is always step back and think about the sanity of the numbers. That's the problem with the 3.6 million individual one, is that that's not a sane number, given the size of these institutions. And you can see here from the list that it's everything from, the usual suspects like Duke and Harvard, but it also includes the American Psychological Association and strange organizations in Germany that I cannot even pronounce. So these VEVO sites are pretty eclectic. Part of what you can start doing, though, then, is if you reach in and say, okay, well, now I know that I've got data, can I ask interesting questions? Can I come in and say, I'm interested in a particular animal model, who's doing research in the area? And I always use ferret, in part because it usually lists. Oh, come on.
Like you searched.
And not search. There we go. So here's the results, and you'll notice that we've got lots of different symbols here. Part of what you want to look at when you start looking at this is, what's your use case? Are you just trying to find out who the players are? Are you trying to figure out where the power sites are? To some extent, this gives you a sideline look at ancestry, their academic ancestry, because people have published with their advisor, moved on, their students have moved on. And you'll notice that you get some interestingly tightly bound groups, like the purple crosses here, which are Florida, but the Florida people here don't want to play with the Florida people here. And in many cases, what you're seeing there, from a translational perspective, is you're seeing potentially a disease-driven group. Ferrets actually are an animal model for COPD and asthma. My wife's old department chairman actually treats ferrets with asthma. To people interested in, say, other aspects of it. I mean, they're used in different ways. The other aspect, though, is you get lots of little compact communities. If you just ran a PubMed query on ferret, you wouldn't necessarily see the relationships like you can see here. The other aspect of this is we can pick an individual and double click through it, and we end up landing on their profile site at their home institution. That was specifically intentional on my part, right? I don't have to worry about keeping my data up to date and fresh. A senior investigator, for instance, doesn't change their spots that often, that if the data is a little stale, it doesn't really make any difference. The indexes are pretty stable. The other aspect is that if you're asking the wrong query, we wanted to be able to help people figure out how to refine the query. So my query here was ferrets, and what you're seeing here is that my tool actually takes your query, looks up the terms in UMLS, Unified Medical Language System. It has indexed all of the data using UMLS and extracted the UMLS concept codes. That's the C number there. And when you run a query, it queries for that number and all of the descendant numbers, right? So if you ask for a term that isn't necessarily the best term to use for that concept, but it's still in UMLS, you'll still get decent matches. And if you come in and ask for cancer, and there's a neoplasm mentioned down below, you will get a do not query for cancer. Because you will get a graph that will consume the screen. It's amazing how many people, their first query is cancer. But the other thing you can do with this is expand and contract the focus. So a ferret turns out to be other domestic animal species, non-primate. This is the controlled vocabulary folks giving us word salad. If we click on this, we're actually going to expand to that super concept now. And now that's a nonsensical super concept, but every mention of ferret and any other non-primate gets swept up. Yes?
But the first one was just ferret.
First one was just ferret.
Then you clicked on the super concept and it gave you this.
Yes.
Okay.
Yeah, and if we come down here, now we see that our super concept is domestic animal. The sub-concepts now include things like giant Flemish rabbits and gerbils.
Look at the gerbils.
Lane brought up gerbils this morning from the perspective of epidemiology, right? So I've never drilled down on gerbils, but we're going to see. Turns out that, what was it, Ukrainian gerbils?
Yeah, they're
End up being a disease propagation thing because they have big networks of warrens, and depending upon population density, you can either get plague coming out in terms of total killing off of the population, or it dies off, right? Who knew? I found this out from the English professor. But the other thing to notice is I started with ferret, but it might turn out to be the case that this gerbil community is equally of interesting. And would I've ever thought about asking about gerbils, right? Or giant Flemish rabbits? Turns out giant Flemish rabbits are much of anything. And in this case, there's even a sub-concept of Mongolian gerbils. So if we drill in further, oh, there is. So there's actually a pretty significant community. And notice that in this case, that there are some communities, and you notice the thickness of this edge is actually proportional to the number of shared papers between those two people. Those two people are at different institutions, right? And yet, this person's a central person to this whole network, and they're all at the same institution. Likelihood, senior investigator picks up stakes, moves somewhere else, everybody else stays behind, gets a different color on the symbol. The other aspect is here, where you get a pretty tightly coupled network of collaborators and one out-of-band collaborator at a different institution. Now, what we've done with this in various forms is look at sort of translational capacity and gender disparity in network things, because we can basically look at things like likely gender of an individual if we don't have gender data for the person. It turns out that collaboration networks, even within a campus, look different for male and female investigators in the basic sciences. The odd bit is the male networks are pretty open and straggly, and the female networks are very tightly coupled and compact. So there's just different forms, different natures of collaboration that are popping out in this as well. So the upshot that I'm trying to get to here is this seems like an initially trivial exercise, but what happens is you point this at an institution and start looking at what you can visualize out of it, and suddenly you can get to an entire different level of perspective on the nature of the institution and how this institution differs from another institution. And believe me, some of these graphs, institution to institution, look radically different. The other thing you can start doing here is go very meta. So here's a plot which is number of papers from the institution and the number of authorships from that institution. And it looks a little weird. You've got this outlier out here of Harvard, right? So if you decide, I don't want to see Harvard, we can zoom in by clicking on a point in the graph and constrain the bounds. And now, interesting things start to pop out. Anybody know what a main sequence in stellar evolution is? So the astrophysicists have this notion of stars starting out along what's called the main sequence. Starts out as a nice little white dwarf, turns into a yellow star, eventually ends up being this little black dwarf or brown dwarf at the end of its lifetime, unless it goes supernova. That sequence of evolution is really a notion of you start out with a certain mass as a star. Physicists have basically identified what's going to happen. Well, the interesting aspect is there's a little bit of swipe over here, but it looks like there's a main sequence of institutional characteristics on numbers of publications and how many authors are coming out of that publication. And the interesting bit when you get into this is many of the profiles platforms are biomedicine specific, but many of the VEVO instances are run by the main university library and include everybody across all disciplines. And so what happens then is you start seeing some very interesting patterns start to occur. You can begin to see, for instance, from an interdisciplinary perspective, interdisciplinarity as a concept can be interestingly identified because we've got appointment information. You can start saying, instead of showing me people, show me this department and how much they collaborate with other departments on campus. Right? And what impact has that had on funding? Because you've got the funding data too. This comes back to information friction. Sometimes you have to keep your head down and not bring that up in a meeting because it either causes a provost to come down on certain departments because you put names on dots, or you've got people who are trying to create cultural change within an organization, and the question is, can you use these data to drive that? All right, so let's go back to here then. So that was CTSA search at its most compact. At that point, Blaine walks in the door. I get totally distracted and start dealing with 16th century Elizabethan scholars, right? Which was an interesting exercise, but you should have come to this morning's talk. But the other thing that's happened is all of a sudden NIH is trying to work on this thing called Sciencv, and they decide they want to get us to try to cross-link things in. I put integration in quotes because they gave us a static dump and they never stood up an API for us to demonstrate what was one of the major primary aims, which was to feed data out of authoritative platforms at the institution to auto-populate things for the investigators in Sciencv. That was not a technical issue. It was pure and simple the fact that that project is being done by a contractor, and the contractor wasn't particularly eager for their data to get exposed at that level. So, I mean, we did it, but it never really became what we were really seeking to achieve. The stubs question, I think, is the most interesting one, and that comes back to this notion of identity, right? My name in PubMed is marginally ambiguous. There's a Dietrich Eichmann in Germany that does biomedical research. So if our full names are mentioned, totally disambiguous. If it's first initial, you got somebody's working on informatics and somebody's working on, I don't remember what, but it's not me, right? That's an easy disambiguation. The question of, anybody want to guess what the most common surname in PubMed is? It's Wang, right? And there are unique names in PubMed that have 30,000 publications across a dozen different domains. Clearly not the same individual. But as Blaine was mentioning about power laws, right? That individual's way over there on the left side of the graph. You get 5 surnames out and you're down to thousands. You get 10 surnames out and you're down to hundreds of publications. And at hundreds of publications, now you're into the notion of just how many co-authors you've got in a PubMed publication, right? And people with CVs with 200 publications in the name being a matter of course, because they're in the middle of the pack, because they touched a petri dish in the lab one day. A little extreme, but not too far afield from an attribution perspective, right? So there's that. So identity now becomes an interesting thing, because if you want to talk about who did the work, just because they're a co-author doesn't mean that they know the whole project that you need to chat with. You need to figure out who was it that basically did the knockout mouse, or who was it that actually did that analysis that teased out that that was that particular gene as opposed to one of the other genes in the candidate. The other aspect at a completely different scale is this notion of they're still stovepipes, right? And so Eric Meeks at UCSF and I have been working on this thing called Crosslinks, and this is paying the community back. All the data I'm talking about is sitting there on open Sparkle endpoints. Right? Eric plugs into services. He's running a profile system, right? He does a query, gets back a candidate list for PubMed IDs on here's an author list of the third author's got this URI sitting over at Duke. He plugs that on the fly into his profiles page for a local investigator. When you bring up their page, you can click on the co-author and you're over on their Duke page. Right? And all of a sudden, instead of having a stovepipe system, you've got one big profiling platform. And actually, I'm missing the VEVO strategy meeting tomorrow, which is talking about, where to take some of this stuff. And that's fine, because I committed to you guys first. The other question is, refresh is really problematic. Harvard takes me 2 weeks to collect the data. And that's a process sitting there nonstop for 2 weeks, as fast as it can, saying, give me this URI, give me this URI, give me this URI, just because of the scale of the data. Pure, on the other hand, a refresh takes me about 90 seconds. And so somewhere in between is a sweet spot for having the currency of the data becoming not an issue for those edge things of newly evolving new event kind of things. In other words, suddenly you need to know about the opioid crisis. Who on campus is doing opioid work? I say that one because NCATs and the CTSAs are wound tightly up about that as a problem that NIH dearly looks to solve. And those kinds of on-the-spot information needs become something critical to try to understand without pre-building a system to tackle that particular question. And then, as you've seen, there's a bunch of macro concerns about what can you do internally with disciplinarity, with gender, with disparities on funding. Is it fair to point at an English faculty member and say, you're not bringing in near as much as this person over in anatomy and cell biology, when the funding scales are orders of magnitude different? So comparable information becomes now suddenly possible to do. H-index as a promotion metric is crazy if you're talking about English literature. It's marginally useful in other domains. H-index is a weird index. So, next phase, polyglot. Yeah.
When you say refresh, Are you building a data warehouse of some sort? Are you doing a federated search across common data elements? How are you making that?
So the ideal initially was the data harvested were going to be used solely to create the index. And then we would always point back to the home profile. The problem is now that there are things we'd like to be able to show that the home profiling platforms don't represent to the outside or require cross-institutional connections that profiling systems haven't anticipated a need for.
So they have no common data model. So either they don't expose it, or
Yeah.
they have a different
Right.
data model, and you gotta map it or something.
So even within VEVO as a movement, 2/3 of the platforms are still running 1.4 VEVO, and the rest are running 1.6, and how they represent a person's name are different because of this unfortunate experiment with V cards.
Informatics classic problem.
Yeah, exactly. And coming back to the architecture diagram, that's the reason for that giant yellow box in the middle. Because all I have to do is, if I can figure out how to build a connector that can transmogrify that data into my model, then I can give you back all of your data and everybody else's data in whatever model you're looking to have. That's why I do it this way. Now, the upshot, though, is we have threatened to build out our own platform that basically never comes back to the home profiling system and shows you everything about the person locally, because you can build new tools that require that level of data integration. Stay tuned for phase 3. So phase 2, Polyglot, this was, okay, grants and publications are great, but it's post hoc, right? You only know about the grant after they've done the preliminary work, because they're not going to get the grant funded unless they've done the preliminary studies. The publications, you have to have done the research, right, before that happens. And the profiling systems, for the most part, use those sources as their primary, if not only, source of information. Because that's what the libraries have, or the VPR's office. Institutional tracking systems get really interesting. So at one point, I had credentials that let me see full text IRB submissions for the entire institution, wearing my CTSA hat. You got to know not only about who had successful funding, but who was pitching new ideas. Now you're into the mode of, you think personal health information is sensitive. You want to talk about an investigator's exposure of their planned project as being sensitive information. But yet, that's exactly what you'd want to have as a vice president for research if you're trying to pre-position an organization into a newly expanding area where you haven't yet struck gold. So from an institutional planning perspective, those types of information sources become really critical and are near real time, because you're looking at the live successful and unsuccessful IRBs, you're looking at the unsuccessful grant abstracts that are lurking around in sponsored programs, in addition to what's in NSF or NIH. All right, so the idea was to get to more informal interactions. And the place where we started was, at one point, LinkedIn has labs, right? And they, in a crazed moment of insanity, stood up this notion where you could log in with your LinkedIn credentials and it would show you this, which was the map of LinkedIn links between you and everybody else in the cloud around you. So this is Melissa Hendel's graph. Melissa is interim director of the OHSU Medical Library and the PI, or the contact PI on CD2H. Melissa's at the middle. This is the informatics ontology world. That little purple cloud over there are zebrafish people. Why? Because Melissa started as a zebrafish researcher. So you get these interesting networks. You go to somebody like Holly Falk-Krasinski, and Holly's got 5 times as many points here. Holly started out, when I first knew her, as being the person who really spun up Team Science at Northwestern and started doing the Science of Team Science conference series. And then she jumped ship and became Vice President for Global Academic Affairs for Elsevier, right? Now, if you want to talk about gatekeepers, notice this little blob over here. That's Elsevier Labs. And you notice that all those edges go over to, for the most part, Holly. So if you want an inroads to Elsevier Labs, who do you go talk to? You go talk to Holly, because Holly's a person who's been an academic and is willing to talk to people and broker a relationship into people like Anita Van Waard within Elsevier Labs. So I thought, well, gee, can we manage to screen scrape all of LinkedIn for this? The answer is no, because you had to be logged in as that person to get this data. It took me a while to figure out just how to pull this data out. Once I was actually going to conferences and saying, here, sit down, log in. Okay, thank you, now go away. And we actually did a Science of Team Science paper looking across 4 or 5 colleagues in different roles and just how different these maps look like and what we could do with them. And of course, they immediately, not immediately, but within a year, shut down the whole interface. And when you go asking them, can we actually get into this data, they never return your phone calls. So I started looking for something else, and switching totally into OCLC stuff. This is basically library cataloging world. There was a study done by Patuelli in 2012 looking at relationships, right? And collaboration and mentorship are really things that, if you think about it, are in those research networking tools, right? Who was your PhD advisor, right? Who have you co-authored with? Those are strong, tight, permanent things. LinkedIn is up here, right? Oh yeah, I met that person once at a conference. I'll go ahead and accept a link request from them. You know, when I started out, I popped up to about 100, 125 links. I thought it was hot shit, right? And then Holly sits down and goes, oh yeah, I've got 2,500 links. And they finally turned that off, and they won't even show you how many links you have. They cap it at 500 because people were turning it into a contest. And in fact, that's what happened between Holly and Nosh Contractor at Northwestern when we were doing this, is all of a sudden they both started trying to get the biggest graph before I did the paper at the Science of Team Science conference. But the reality is, there are these gradations of acquaintanceship, right? I have a conversation with Blaine, it gives me an idea. I have no way of attributing that except in the acknowledgement section of a paper, right? And so what she was picking up here, Patuelli, was, you know, ontologies lurking out there in a number of domains. Friend of a friend shows up all over the place because everybody, for good or ill, has decided that's the way in which we describe people in their names, right? The relationship thing is a little generic, and Patuelli was looking in traditional library contexts, and she picked up music as an ontology. But the reality is, this guy named Randy Trigg back in '83 did a PhD dissertation which basically teased out this whole taxonomy of bibliographic citation and how the science community cites things, right? And the relationship structure there is a really interesting one to look at. So this is Melissa's diagram. So you've got a paper here that's written by a person named Karen, was influenced by a particular data set. That particular data set is what they used for the paper, but it's actually driven off of 2 mouse constructs done by different people, right? So the question is, do Stacy and Christy get any acknowledged credit for a second degree construct when in fact the data set in the middle wouldn't exist without those 2 constructs having been created? This notion of transitive credit of scientific discovery is what Melissa was at. Well, so then the question is, you're going to violate your license agreement with Scopus or do something else? Enter PubMed Central. There's an open access component. It's up over 1.6 million full text papers. All of the images the PDF. If there were supplemental data as videos or whatever, it's in these tar files. Right? Huge amount of data. 500,000 of those have acknowledgments. Right? You take that apart, you get about 1.3 million sentences, and now I'm back into Blaine's notion of big data not being mined. You parse those out into the sentence markup stuff you did in 9th grade grammar, and you get roughly 6 million parses. And if you fragment those out into tractable pieces, you're looking at roughly 100 million fragments, right? Which isn't that big a deal if you're going to do this as a database exercise. PubMed Central, as an example of this, 27 million, actually these numbers are slightly out of date. So it's looking like we've got roughly about a 10% sample of all of PubMed. Okay, simple cases, when you look at the acknowledgments, EK analyzed the data. First thing you recognize in this is that for good or ill, the abbreviation usage within acknowledgments is massive. EK, in this case, turns out to be one of the co-authors. So first thing we had to do was sift that out. But at this point, coming back to the attribution ontology, we know who was doing the data analysis. That only appears in that single sentence in the acknowledgments. Now, what you can do with that is we can do part of speech tagging on it. So this is a plural noun, and that's a determinant, past tense verb. A parse tree gives you basically, it's a noun phrase and a verb phrase, and the verb phrase has got a noun phrase in it. Stuff you diagrammed in English. That's cool and simple. Then you get these. And there's a remarkable number of these. This sentence is 8,000 characters long as one single run-on sentence. It's incredibly target rich from a clinical study perspective on who was the trial manager, who were the participating sites, who the contacts were at the participating sites, et cetera, et cetera, et cetera, et cetera, et cetera. Parsing this on a modern machine takes 15 minutes of processor time. Right? That is forever. But once you've done it once, you've got it. Right? So that's what we've done. We've gone through and we've basically mined all of the acknowledgement sections out of all of PubMed Central Open Access and parsed them all out. And now as they release on a day-to-day basis, we do the parses for the new stuff that day, and it takes about 2 hours. So I've got machines that are just basically lurking in the machine room, and they wake up at 2 a.m. saying, "What you got new?" And they spend the rest of the day cleaning up the day's work. But what you get to in the end is you can actually start looking at these fragments. And I do the fragments because if you think about how complex sentences can be, you'd like to sort of elide away, prune away the lower level noise stuff when you're looking at the macro structure of a sentence. Right? If I'm talking about, say, a CEO of a company, you could see John Smith, comma, president of blah, 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 comma, today said something. Well, the said something and the name is a long ways away because of that parenthetical sentence. That parenthetical sentence is carrying information, but it may not be what you're trying to make the connection. The problem with the standard statistical approaches is the farther away you get, the more problematic your probabilities are, because they don't understand the sentence structure, which is why I go to the pain of all that CPU time. CPU time is cheap, particularly when you have a cluster in your office. All right, but what that means is we can come through, and once we've got the parse trees, we can do things like, well, that is an author name. That 2-letter acronym is actually the name of the second author. And data is a resource. So if you start coming up with vocabulary that can allow you to match this, suddenly you've got a notion of a given entity, an author, providing a given thing, a resource, to the paper. And when you start doing that, again, big numbers, the distinct patterns of that syntax structure, you end up with 4 million of them, which means if you're going to try to do every one of them, as we were talking about this morning, Soli goes crazy. Soli's my graduate student who was doing the ESTC part of this. She had 480-some thousand patterns to worry about, and now we're looking at 4 million. But you can see that there are some interesting recurring things. There's 1.7 million of just noun phrase comprised of this work, right, or the project. And if you start throwing things away, let's stick with top level sentences and get down to only ones that mention authors and persons, and suddenly you see author, weird noun, person. That weird noun is the system misclassifying thank as a noun. What's happening here is you're seeing so-and-so thanks this person. Prepositional phrase, for something. So you can start writing extraction patterns, and this comes back to this notion of let's pattern match against the structure of the tree. So we're looking for a sentence where the first bit's an author tag noun phrase, the second bit's a verb phrase, where the first word in that verb phrase is thank, and we're interested in these two pieces. And within that first piece, if it's a noun phrase of exactly two pieces, then the first piece is a first name and the second piece is a last name. And likewise here, the noun phrase in the determinant is actually the resource. What we then get when you start just sucking that data out like crazy is you suddenly find, when you dump it into a table, that you're getting nice, clean people references. And when you jump into relationships, all of a sudden, that what's being identified is the kind gift of a particular protein and helpful discussions, that sort of indeterminate contribution to a paper. And for a different person, you get a really specific thing, a rabbit polyclonal antibody, or two specific plasmids. Now here's an interesting bit. We now know, without having to know ahead of time, what the name of two plasmids are. Because if we get X and Y plasmids, those two things are names of plasmids. You take those two things and recognize them as plasmids and come back in, you discover that somebody might have said, we thank so-and-so for the EF or ECFP, period. You didn't know what ECFP was until you found this one. And so this iterative notion of cycling through the data over and over again, you find yourself deepening down, picking up whole lists of protein names. You can actually discover new protein names that the curation sites haven't even come across because they haven't curated the papers yet. So discover becomes an interesting possibility as well. And what you'd start seeing here is collaboration's high frequency technique. We thank so-and-so for a particular protocol, particular resources, and so on. So next steps. This is one of these long tail distribution deals, right? We got a lot of patterns. And Soli's graduating. So students insist on graduating. But primarily what we're looking for are looking for things like, right now you can go to NIH Reporter and find out all the grants. But if you want to ask about what's the grant funding pattern internationally for a particular disease, there's no place to go to. But those grant numbers are in here. I can tell you what the grant pattern is for the Taiwanese Science Foundation, right? For a particular discipline, because if you take a look at enough of them, you slowly but surely build up the right pattern for it, in the same way that an NIH grant number has a particular pattern. And so what we're starting to deal now with is we can actually lift out grant funding patterns for international agencies and who they're funding for what out of this data. Haven't yet rolled it into CTSA visualization, and Melissa's whole thing is this whole attribution ontology bit. Right? So that's the next step. Okay, so that takes us to September. And in September, actually beginning of October, we found out that the team that I'm part of actually got the CD2H award. So NCAS, the National Center for Advancement of Translational Science, put out an RFA for a Center for Data to Health, which was designed to fund mom and apple pie. No. catalyzing the effectiveness of the informatics groups across the CTSA consortium. And there were some very large aims. You notice slide shift to official structure. First one was, aim one was data, right? There's lots and lots of data silos lurking about. This has been a perennial problem. The Big Data to Knowledge initiative within NIH and BioCaddy out of UCSD to try to create meta-indexing for data resources have been thrown at this. The CTSAs own a lot of data warehouses, right? And those data warehouses don't necessarily speak well to themselves, let alone with each other. So the question is, can we do something from a data practices and demonstration perspective with respect to data? Secondly, you're not going to do anything with the data without the software. This gets to, the default early notion of a good informatics proposal was you stand up I2B2 and you stand up REDCap and you're an informatics team. It's gotten a little bit more complex than that these days, but the reality is it's very hard to tell who's actually contributing to or coming up with new solutions that are of interest to the consortium as a whole. So just as we talked in CTSA Search primarily about biomedical concepts, data and software are lurking out there as things that can be represented as well. And I don't know whether this was Melissa making a joke, given that my mustache is disturbingly similar to this guy's. But what was not in the RFA that we threw into the mix, and is the piece that I own, obviously, is if you don't know who's doing it and who to get in touch with, who the right people to talk to are, then you're going to founder about and end up looking at a bunch of basically abandoned GitHub sites and so forth, rather than being effective in how you build a collaboration to take your environment and your relationship to the rest of the consortium to a next level of efficacy. So there's that component. And then finally, there was a whole notion of technical and cultural evolution. Notice we've gone from very low level down in the roots notion of what's a token and what's a noun phrase up to these very broad, very fuzzy concepts. Right? But it is a natural progression in terms of what we'd like to do with the platform. We're looking at, for demonstration projects, looking at a yet to be determined set of rare diseases, because one of the interesting things about this environment is rare diseases are so scattered from a occurrence perspective that an individual, even the large CTSA, may not have the study power to do anything with. But if you can manage to aggregate and start making cross connections, pull in additional sources of data, do that data mashup, that potentially you can do more tractable and more insightful things. Which leads to, this is your worst nightmare in terms of an organizational structure, and this is what we're basically looking at. So the original aims, people, expertise, data, software is across the top, evaluation, education were components. Problem was we needed to make sure internally that we knew what each other were doing, and so we came up with this PCO thing, policy lead, an operational lead, and a collaboration lead, and some of those roles flip-flop. So I'm policy on people, and I'm coordination on software. Right? And you'll see similar cross-linkages. Prospect is we're now at a point where we're getting ready to reconnect out to the community, and the informatics domain task force meeting on Friday of 2 weeks from Friday, is where we're going to start engaging with the consortium informatics leads about where we want to take some of this stuff. The prospect is we want to basically start doing what we've already been doing, at least from my perspective, with CTSA Search and this data connectivity notion, start doing that in the other domains. So as an example of this, people that don't show up in publications, but are interesting people to know about, is you take I2B2 or REDCap as query terms and you go hunting for repositories in GitHub that mention those terms. You lift out people's names of people who are running those projects. This includes the primary open source platforms themselves, but also everybody who's forking those projects, often doing derivative work. And even more so, who's committing code? And all of a sudden, instead of looking at PIs and grants in NIH Reporter, you're looking at the sysadmins and developers at the lower end and trying to figure out, by bubbling up, who in that middle scale is the right person to talk to that, no offense intended, know what they're talking about with respect to the activity on that project, right? Because they're doing the day-to-day oversight. That notion of connecting quickly and readily to that middle scale is the desired goal. All right, so this was, actually went faster than I thought it was going to go. So how does this cross-connect? Well, to a great extent, we sort of alluded to this already this afternoon and very definitely this morning. I started doing CTSA search, and Blaine shows up on my doorstep, and we end up doing effectively exactly the same thing with Shacosphere, except Shacosphere is 408,000 MARC records of stuff that most recently is 1,800. Right? But the reality is, the ambiguity, even in those highly curated, long-lived records, is as diffuse and problematic because of how people's names are spelled and so forth, as it is with an ambiguous Asian name in PubMed. The other thing that's happening with this is there are interesting side effects, like you get all this geospatial relative positioning stuff where you can begin to cross-link to people with other interests. We mentioned the map of early modern London that Janelle Jensen at U Victoria does. All of a sudden, we've got identifiers and she's got identifiers, and we can drop you from a record on our site of somebody having published at Chancery Lane and click on a link and you drop through the rabbit hole and look at the map of early modern London at where Chancellor Lane was in London at the time. That level of semantic integration is what we're shooting for across the spectrum, both with Shacosphere but also with CD2H. And then finally, I got pulled into this exercise that Mellon has funded on linked data for libraries. For those of you who aren't in the library community, forever and ever and ever, since the birth of computers, libraries have used a format called MARC for catalog records. And that, I won't use the firm. I won't upset you.
No one's upset.
Yeah.
I'm kidding.
My opinion of MARC is, shall we say, less than helpful, because it's inherently 1960s technology. It was designed to be magnetic tape and compact. What we're doing now is Library of Congress has been working on this thing called BibFrame, which is a linked open data ontology for cataloging. And what LD4L is doing, both labs and production in the current form, is looking at, okay, so you've got that, what happens with the data when you start working with that? And so I actually have, and I wave it around frequently, I have the entire Harvard, Cornell, and Stanford catalogs as linked open data on a little flash drive. Right? It's 10 to the 10th triples. But you can do really cool stuff with it. You can ask questions that you can't ask a library catalog. And shifting away from biomedicine and into what happens with domain mashup and translation, if you will, in the other disciplines, when the library becomes a queryable thing that you can make those kinds of cross connections on, suddenly you can find stuff out that you could never find out before. The one we're using as an example this morning was the fact that, I wasn't aware of this, but apparently it's known to the French, is that in France in the 1600s, there were a lot of female printers running print shops. We only found that out about the England stuff when I started getting all these female names out. Right? And in some cases, they were inheriting the shop from a dead husband. And in other cases, it was pretty clear that they had been running that shop forever. Right? And that's just something that pops out of the data because you can look at it sideways. Because the published field has never been anything other than just something to slap on the screen. It's not something you can really seriously query on from a traditional catalog system. And that's because the catalogs were designed to do one thing, get you from an information request to a slot on a shelf, and not treat it as something to be analyzed in and of itself. MARC was never amenable to that. Mutating the data in this way suddenly gives you any number of entry points for querying ability. And that opens up whole new avenues of discourse and research. And that's what we hope to accomplish on the other side of the fence too, which is why I find it interesting to live in both of these worlds. My work on CTSA search gets informed, I hate that word, by Sciencv and vice versa. There's a platform, right? All of the force graph stuff, all of the modeling stuff, all of the querying and the Sparkle tag libraries that pull the data out of the information stores are common across the two platforms. It's the skin that's different, and it's the data that's different. But the tool becomes something that you can apply to additional new domains, and with every new domain, your ability to think more generally about the problem makes each one of those solutions more robust. So, with that, I'll quit. I do have to acknowledge both the admin supplement to OHSU for the Sciencv stuff and our new U24. Sciencv was an internal project at University of Iowa, and then our Mellon project. If you're interested, all of those platforms, including the linked data stuff for service level acquisition, are out there and available for anybody to use. Questions? Stunned silence.
Are there any plans to bring in the rest of the CTSA community into CTSA search?
That is AIM 3.2.
Okay, because obviously we are a CTSA institution
Yes.
and we're not there, but we have our own platform.
And
right?
we just need to have a chat. I mean, I'm perfectly willing to
I'm
write
not
a
really
one-off
the one
wrapper.
with the chat.
What platform do we have?
I would say it's research directory. I mean, that's what, but I
That's
don't
not
know.
VEVO enabled though.
It doesn't need to be.
Doesn't it?
No.
What does it need to be?
Something I can get at.
Oh, I think you
Why
can,
not?
yeah.
Well, no, I'm serious. I mean,
No, I just
Okay,
see, I
so
see
you
the
convert it
useful.
on the fly.
I'll convert it on the fly.
Yeah, I mean, it would be good for us to be there, right, Brad?
Yeah.
Yeah.
How much data do you have on how many of those CTSAs are searching it? You know, let me back up. How many do you have in there of all this? What, 64?
I basically have half of the consortium.
You have them. So and we're not one of the half because of
Right.
what you said, right? How much are they using it of those half?
That's remarkably variable. And that, to a great extent, depends upon just how much into team science and translational research brokerage the given CTSA is into. So the California schools are using it a lot, primarily because of UCSF and what they're doing with that single unified platform they're working on. The original schools like Flora and Harvard are really plugged into this as well. You get to the Michigans, which is a pure site, and they don't really use it at all. That's in as much at the grassroots level, the research community may or may not be even aware of the platform because of communication latency.
Right. We're up for renewal, and I'm wondering how we can use this as a metric once we get plugged into it. Other CTSAs using this in terms of a common metric to enhance their application?
So, I won't name names, but the prospect of what did your pre-award collaboration network look like, and what does your current award collaboration look like, particularly across a translational spectrum, gives you either a positive or a negative indicator of have you made a difference, right? Both on campus and off campus. So, for example, if I come back here to the institution map, you can do things like hover over one of these schools and be able to see just what is your collaboration network in aggregate. So, for instance, here's UCSF. Right? So UCSF's connectivity versus Iowa's connectivity doesn't look too different, but when you pick, well, Michigan we don't have the data for, right? Illinois, here's Northwestern. If I manage to, sometimes the map scale is a little problematic. There are cases where we've got multiple CTSAs that are almost on top of one another at this map scale. But the prospect of demonstrating collaboration and translation was sort of early goals in the consortium. These days it's more clinical trials, actualization and so forth, and there the ability to quickly identify potential trials coordinators at a remote site, if you're talking about a multi-site trial, is something we looked at. We actually have a separate platform that we built at Iowa for the coordinators, where they can indicate what their skill sets were and what percentage of time that was still available that they weren't already booked for. And an investigator on campus could drop in and say, I need somebody who does this and this and has got at least 15% of their time available. And you get a list right there. And the coordinators loved it because it kept them fully employed. So there's a lot of that kind of friction reducing mechanism. Right? So if you're interested, I'd be happy to chat about what we could do with your data and what you could use the data for.
I may call you up on that. Great, thank you.
Yeah, because part of our mission for this is to get past that 50% coverage to 100% of the coverage, even to the extent where we're on the hot seat to stand up a standalone VEVO compatible instance of something that if you're an investigator at a site that doesn't have a profiling system, you can log into our site, build a profile, and you'll exist in this network as an individual, even if your institution won't do it. And then the hope in the long run is the institutions take on the maintenance of that data because there's perceived derived benefit. Now, that's always a challenge because of the distance on the impact of, can you get somebody to admit that they derive benefit from it when they're generating a multidisciplinary team to go after a grant proposal. When I was informatics director, even with an audit trail, I couldn't get investigators to admit that they'd used our resources as part of our annual progress report. Even though I could show you got this and this and this. No, it didn't. You logged in at 3:52 p.m.
I seem to be the problem child here. What
That's
about
fine.
the ORCID? We have this ORCID ID.
Yeah.
That,
Yeah.
how does that fit into this? Have you integrated that?
So, yeah, so I actually download the full ORCID dump monthly. So it's roughly 3 million identifiers. So at its core, ORCID is just trying to create a distinct, unique URI for every person, basically, that's going to be of interest. If that existed, and you have the ability to hang that connection to a PubMed record, then there's no need to disambiguate, right? So in a long-term goal, this becomes solved problem, right, in terms of identity. Once you've got that, then a local identifier, this is my URI in Loki, and here's my ORCID ID. It becomes one and the same thing. So, for instance, I can show you. So there is an open VEVO platform at the moment. We do a quick search. Here I am as a person. And there's my ORCID ID, because that's how they're doing authentication, is through the ORCID logins. And from a publication perspective, all this stuff was either pulled off of Figshare or straight out of Scopus through ORCID to populate this profile. So the idea is to minimize the effort for an individual investigator to create an identity, have that identity authoritative, and then from there, tools like ours can really start to do some serious work. We do the same thing in a slightly different fashion within Loki. We pull from PubMed, from Scopus, from Web of Science, and a couple of minor ones, and show you a cluster of co-authorship patterns that basically, for most people, you've got two clusters of here's your postdoc work and here's your current research collaboration network. You'll click, and you're done. We did the entire College of Dentistry over 2 pizza sessions at lunch. So they could do their reaccreditation exercise and have up-to-date CVs. But yeah, I'm happy to chat. I mean, we're basically now funded to make this happen. And that's always been the perennial problem with the consortium, is that the individual sites never had consortial level activity on their budgets. It was all perceived as unfunded mandate. CD2H is extra hub. We're not a hub. We're not beholden to any hubs. We're funded to just start doing stuff.
This is part of your CTSA deliverable, so to speak?
Yeah.
It's not a sub-project that you investigator-initiated project. This is part of what you said you do.
Yeah, AIM 3.2 was stand up an open VEVO instance. AIM 3.3, get all the Elsevier Pure site login credentials. Yeah, so AIM 3 was pretty clear, step by step, what we're planning on doing. Because I've been thinking about this, obviously, for a while. Software data, a little fuzzier, but there are far more wicked problems. Probably half the people in the room don't even know what we're talking about at these points.
It's great.
Other questions? Yeah.
I don't really have a question, but you have touched on something that made me, I always wondered why the methods section of papers was not indexed in PubMed or something like, was not included. And you make me realize that, yes, that should be done.
Yes.
Because the content's there.
Yeah, and the case in point I use for that, I always used my wife before she retired as my skeptic in this regard. And she goes, mostly what I look at is the methods section of the paper, because what I want to see is if I can use their technique for my stuff, right? And more interestingly, she says, on campus, I use this core and not that core, because even though they're using the same protocol, these guys are using this particular reagent and this particular medium, which makes my cells, and that one doesn't, because they're using a different medium. So even something as fine-grained as choice of agar makes a difference? Yes, right? And so the method sessions are huge, right? In terms of, can you be repeatable in that work? What I also find interesting is the discussion section. People start to get speculative, right? If you want to talk about, I had a PhD student who was working on burst detection. Can you actually detect a new thing coming into being in the literature? And you can actually look at discussion sections and people say, well, we can't prove it, but we believe that this and this protein are responsible for this effect. Right? And then 6 months later, you'll start seeing papers saying, protein X is responsible for this. And so if you're looking at leading edge, how do I get out onto the wavefront of new research? If you can analyze that material, you can be that much further out of the gate that much more quickly, which comes back to, I mentioned information friction. That actually comes out of finance. And the concept in finance, particularly international finance, is if I know something before you do, I can react in the market more quickly than you can and gain a financial advantage. If you think about this as, the phrase I use is academic competitive intelligence. If you can figure out what your colleagues and neighbors and other people who don't like you as much are doing and anticipate their next move, you can do a better job at positioning your research. Now, it doesn't handle the opioids of science research. But for most of the standard R01 research level stuff, yeah, you can pretty much predict where the trends are leading when you start looking at it in that way. Other questions? Never let Blaine say a word. You want to say something?
I was going to say you were setting sort of Luturian there when you were describing the different medias. I mean, it strikes me that when we did initially start Sciencv, when I came to talk to you about it, because we liked what you'd done with that initial version of CTSA Search, the sort of vision that we had for getting at what I was calling non-authorial agency in early modern literature, that is thinking about how people besides Shakespeare were involved in the production of Shakespeare's book. It was partly that idea of getting down into like the methods section of those publications, like pulling out names of people, the places where these things are being generated, and thinking about how those other factors contributed to the production of literature. And a lot of times it is actually early science. A lot of the documents we have in that catalog are early scientific ones. And I don't know. I guess I would ask you this question. So as you're talking about sort of next steps, it sounds to me like a decent amount of that has actually been informed by our conversations about what we could pull.
Sure.
And so I'm curious if you could talk a little bit more about that. Like because I think, for example, that you've become more interested in locational information as we've been trying to dig that out of Sciencv.
Well, with Sciencv, yes.
With CTSA Search, I've seen more of that popping up on your work over there since we started trying to dig into it. And
that was driven on a very specific request from a farmer, which I will not name, who was dancing around offering us the potential for funding, and then basically walked away when I built a feature into it. I guess I should have held out longer.
Yeah.
But what they were interested in was wanting to be able to spatially constrain it to say, okay, well, I'm interested in people who are working on ferrets, but only in the Midwest.
Mm-hmm.
From a perspective of you get too far afield and the temporal latency, not as much in the US, but in international collaboration, becomes problematic because nobody's in the lab at the same time to have a conversation. So that was really the driver, was that they were wanting to basically say, we want people within, a day's driving distance of this particular research lab of ours, as opposed to having to worry about somebody who's on the opposite coast. So it's pretty mundane.
Yeah.
But all of a sudden, bang, we do that on that side, and suddenly we can do it in Shakespeare too. And the driver for this, the English short title catalog stuff, just has these approximate references of printed by John Smith at the sign of the Eagle and Child, which is, on not Fleet Street, but there's a pub name and a street name or a church, right, as an approximate spatial reference. Janelle Genstad at Victoria has those landmarks, right, but she doesn't have the pub name because it was never viewed as being important enough to be mentioned. But all of a sudden, we can tell her it's 3 doors down to the north, right? And she's got the buildings drawn as little tiny buildings, right? So all of a sudden, she can count buildings down and say, there's the Eagle and Child. And by the way, if you're ever in Oxford, go to the Eagle and Child. It's a cool pub, and it's been there since Tolkien. But prospect is, all of a sudden, Fleet Street, you warp over to Wikipedia, and Fleet Street's in Wikipedia with Latin long coordinates. And so you plug that in, you do for the rest of them, and you can start doing distance calculations on these references and start saying, well, what was the print culture in and around Fleet Street from 1500 to 1620? And that's not a question you can ask a library catalog, because it's turning the data completely inside out. And that's also true in the solar space. example I use there is there's a guy at Duke who does this particular protein for cellular membrane integrity, which is why you don't leak, right? And he never shows up in the co-authored list, but he's all over the place in terms of acknowledgments because he's handing his reagents out to everybody who asks for them. Huge impact on the discipline, no impact whatsoever on his CV. Yeah.
And I just want to piggyback off what you had just mentioned. Well, that algorithm or that query that you were talking about that allows you to see people that have contributed but maybe are not co-authors, would you be able to use that to see librarians that may have helped out? Like you mentioned that scientist that gave out that reagent, but it's not on this, it didn't make it to the CV, but it did have an impact. Were there librarians or informationists that may have contributed to a paper or to a project? Could we use that same system to kind of see their impact as well?
Yeah, and therein lies a really interesting challenge of volume explosion on data. Because if you think about what could your contribution as a librarian be, and if it's disambiguating, creating a same as assertion of this authority record in the Cincinnati catalog is the same as this VEVO record or the same as this record over at Harvard, that's a value add because suddenly if there's additional information over there, if I've got a same as assertion between the two things, I can look up something over here and say, oh, I can pull data from here as well. That's a contribution. How do you give credit for that? You end up having to attribute the assertion of the fact to a single individual, which means instead of just asserting the fact, you're now asserting the fact plus 2 or 3 other triples which provide the credit, because you've got to worry about the role and who the person is and when they did it. So the volume suddenly plumps up big time. It doesn't necessarily create impact on the overall performance because unlike a lot of traditional data systems where you pull the one strand and you get all the strands, turns out that with this linked data stuff, it can actually be incredibly nimble when you're asking for a particular specific chain of linkage, right? And get just that and get it as fast as any of the modern relational database systems, even though the technology is still pretty young. And that's something that people don't get yet. And actually, it's why I got invited onto the Mellon project. It's because the current head of the Linked Data for Labs project kept seeing me at these VEVO conferences talking about what I was doing with CTSA Search and said, you want to go on to our renewal for this thing? I said, sure. So, he's got 11.75% of me and one of my grad students on the project. But what we're doing is we can actually query that information and effectively provide a catalog-like experience, but the ability, I won't try to do it on the fly right here, but I could pull up a record for like Hugo Gernsback, who was an early 50s science fiction author editor. And he's present in Harvard, Stanford, and Cornell's catalog. There is a VEVO record for him, but those catalogs don't link to that VEVO record. But he's got a relatively unique name. So if I pull it up and say, don't have a same as assertion, give me some candidates, right? And you see a list of potential Hugos, and you can click on one of them, and the minute you click on it, it reloads the page, now with the link. Because that link is there, and there's a link to DBpedia, what shows up on the page that renders isn't a list of people to choose from, his picture and his bio from DBpedia show. That's not data that exists in my catalog data. I'm pulling it live from DBpedia. And it loads like any normal web page loads. So even though the technology seems extremely arcane when you start trying to talk your way through it, the result is that large numbers of small steps end up being very quick to do. And a small number of large steps end up sometimes costing you a lot. And the example I use for this from a computer architecture perspective is complex instruction sets, the Intels of the world, won out, right, from what were known as RISC machines. RISC machines did really simple things, but they done really, really fast. But they just died out in the same way that Betamax died out as a VHS or a videotape technology, because VHS was cheaper. But the prospect is, my little mock-up of VEVO that's pulling using my techniques actually loads faster than the production VEVO loads with the same data, because they're doing more complex things and the technology isn't as good of making that as efficient as doing a large number of small things. And that's really, I think, the clue to this is, don't cache data you don't need to. I mean, if we end up with library catalogs being open and interconnected constellations of points of contact, in the same way I'm talking about cross-linking the VEVOs, right? Suddenly, you can be pulling a page up that's pulling from a half dozen different catalogs. And you don't need to know it. You just need to have somebody behind the scenes providing the linkages and those contributions. And the shift of saying, well, here's an authority record that's just a name and a birth date string. I'm going to sit down and create the appropriate first name, last name, birth date, death date properties, right? Suddenly, now I can come in and query on those dates, where I couldn't query them when it was just this long, complex authority string. So contribution gets extremely fine-grained, which I think is cool. But with it comes the problem of the credit. And that's, there was a research output ontology and then the credit ontology stuff with Melissa and Christy Holmes. That's their thing. I mean, they sort of groove on ontology. I just use it. I play an ontologist on TV. You had a question back there?
When I'm a cataloger, and I've been a cataloger for years, so when you're upgrading all of these names, where do they then live? Are they living your improved name files? One of the issues that we've always faced is exporting records between systems.
Right.
So, and love it or hate it, Mark is our exporting discussion.
Or now.
Yeah, but the vendors are still live in Mark.
Yes.
And without significant amounts of capital, I don't see that changing for, at least until I retire out of this.
I would probably take that bet, because all you need to do is have the ex-libris of the world roll over to a new internal data model, and if you've got a decent editor, who cares? You're still going to be editing the traditional fields, the traditional properties, if you want to shift the vocabulary.
True.
It's just what's happening in the storage engines that changes. But the prospect is, in terms of sharing and dissemination, you could literally say, okay, we've got a new work, right? Here's an author name. We've got a little bit of information. You get it VEVO or LOC or any of the services that we're playing around with, and say, okay, for any of the properties that we don't have locally stashed, if we trust that source, just grab those properties and pull them across. And that's actually, Lynette Rail at Cornell is working on a platform called Questioning Authority. And so Lynette builds out couplers to my services. My services say, come in with a search term like a person's first name and last name, and I'll come back with a set of potential URIs, potential identities. She can pick through those. She can pick one. When she clicks on that, she hits a service of mine that gives her a full RDF dump of all the triples that we've got stashed from VEVO or from LOC. At that point, she's got a serious start at a catalog record. That's local, but the ingest was done piecemeal without having to worry about, the complexities of all that mark structure, because everything is just subject, predicate, object. And if the ontology is shared, BibFrame being the thing that's defining the predicates, then we're speaking the same language. In the same way that the VEVO becomes a cross pivot for me. It doesn't matter where it came from. Once it gets to that big yellow box, it's all the same language.
So why hasn't this already happened in the library community? I mean, I feel like the structure is already there.
Because it's terrifying.
Well, it really, the structure really isn't all there.
Decades
Yeah.
ago.
The structure really isn't all there.
No,
And that's,
because
that's a large part of it.
because LOC is
I was
still
gonna say it.
tinkering with BibFrame.
And and it's been changed, and there's huge issues with RDA and some of the rules of RDA. And the further we get within
Yeah.
that, the more some of those huge issues crop up, like, really bad idea, folks, we need to go
Yeah.
back and punch.
And that's why Mellon funds LD4L, right? Because LOC is just twiddling along with BibFrame and not really worrying about whether or not what they're doing works for anybody but LOC.
Well, and that's a huge point to bring up. And I think that's an excellent point for everybody to remember.
Yeah.
LOC has abdicated their role, if they ever really had it, as the cataloging authority for libraries at writ large.
Yeah.
And it's kind of like, well, we're kind of like us, and gee, it's really nice that the rest of you all live out there, but we do what we do, and we'll kind of come up with this book of really good suggestions and follow them, but they're not rules, and that's kind of where it ends. And that's been kind of the big problem with all of this.
Yeah, we've been, not me, but I end up in meetings with the catalogers from Harvard, Cornell, and Stanford. And it's not so much now, but when I first joined the project, I joined in phase 2. They've been at it for 2 years. They were constantly beating the LOC people over the heads about, you're not doing title right. And the reality is, some of that's changed, and some of it they're dragging their feet on because they just don't have a use case for it. But the reality is, ontologies are composable, right? You can layer ontologies on top of ontologies. If LOC is not going to go beyond BibFrame, that doesn't keep the academic cataloging community for doing an overlay that does the rest of what's necessary, that builds on top of BibFrame, as long as it's not incompatible. That's been most of the argumentation for the last 18 months, is that boundary question of trying to get everything we can into BibFrame, and where they won't do it, can we get them to at least maintain a degree of compatibility against what is wanted to be done, which is nothing to do with the technical components of anything. It's all to do with social.
Yeah, right now it's power
Yes.
and control and cultural shift.
Yeah, and to a great extent, the stuff I was describing in CD2H, same deal. I mean, this kind of stuff crops up over and over again. When I was doing software use and reengineering, same deal. Software reuse is not a technical issue. The languages are perfectly capable of handling modular reuse of software. It's all, I didn't write that code, it's not going in my system. I mean, I literally at one point was talking to an Air Force colonel, because the DoD was really into this stuff, in a workshop, and he goes, what's it going to take for my people to start doing this? And I said, honestly, you're going to have to wait for the current generation to die off, because the next generation coming along is a GitHub generation, right? And he just, in all seriousness, looks at me and goes, I can't wait that long. It's not that he didn't believe me. Other questions? Well, thank you for listening.